It's a new dawn, it's a new day, and with a new day comes a new task. Solving a quadratic equation. See this equation on your screen? It's in a standard ax squared plus bx plus c is equal to 0 form, which we shed some light on in our previous video. Not only that, but we also promised we teach you how to solve quadratic equations. Well, we are here to fulfill that promise. Now, there are multiple ways to solve the same quadratic equation, but to keep things simple, we are going to discuss two methods initially. These are called factorization and completing the square technique. Why don't we discuss the factorization method first? It's always better to start easy and then work your way up. So, can you tell me what the factors of 18 are? Yes, yes and yes. You have identified them quite flawlessly. The product of these specific pairs of factors gives 18 indeed. So tell me this, if we can factorize numbers, can't we factorize algebraic terms? We sure can, and just as easily. But how though? Let me tell you how. Consider the standard form of a quadratic equation. Here, let r and s be two numbers which, when multiplied together, are equal to the product of the first term's coefficients a and the constant c. And when we add r and s, the result should give us the middle term's coefficient b. So if you think about it, we can write b as the sum of two factors, r and s, which leads to the factorization of whole quadratic equation. Want to see all of this in action? I thought so. Let's go ahead and start solving some equations, like this one. First things first, how can we know for sure that this is an equation? Well, the equals to sign gives it away. Moreover, the highest power 2 makes it clear that this equation is a quadratic. This is its left hand side and this is its right hand side. We'll name it equation 1. Now, we'll bring it into its standard form by shifting x plus 20 to the left hand side, leaving 0 behind, and adding negative x to negative 6x. Great! This quadratic equation has now successfully been converted into the standard form. Let's call it equation 2. And now we compare. If we place it next to a standard form of ax squared plus bx plus c equal to 0, we can see that a here is 3, b is negative 7 and c is negative 20. We'll always consider the coefficients and constant with their signs, no matter what. Now, we just learned that r into s is equal to a into c. That is 3 multiplied by negative 20, which gives you negative 60. And to get the individual values of r and s, we need to figure out two such factors of negative 60 that should total up to negative 7, the value of b. And if you observe here, you can tell that negative 12 and positive 5 are those required factors of negative 60, which when added results in negative 7. So this means that negative 7 can be written as minus 12 plus 5 along with the same variable x. It's a walk in the park from here on. We'll take the common from terms 3x squared minus 12x. And then from plus 5x minus 20, factorizing them as 3x into x minus 4 plus 5 into x minus 4. Right off the bat, you'll notice that both terms have x minus 4 common. So if we take it out, it automatically makes 3x plus 5 another factor. All we have to do now is equate x minus 4 and 3x plus 5 to 0. In the first one, we'll shift negative 4 to the right hand side to isolate x, and in the other one, we'll shift positive 5 to the right hand side. and then shift this 3 as well to isolate x. We now have two values of x, 4 and negative 5 upon 3. Lastly, since both of these are the solution of the given equation, we'll note them down in a solution set of x like this in curly brackets. Now this was just one of the many examples of quadratic equations one might come across. I've got plenty of more equations up my sleeve, just like these. That's right, stay tuned for our next video to find out.